Here in Brazil, we have a group called Mathematics and Disaster Risk Reduction in the Brazilian Applied Mathematics Society. We are now thinking about internationalization with the group Mathematics of Planet Earth from Imperial College and the University of Reading.
They work basic on this, how human and ecosystems and how human and land use are influenced by each other in terms of water production, agriculture production, biodiversity, and ecosystem service in a broader way. Well, I think it's pretty central in a way that how you can deal with about a broad aspect of the disaster itself. From the physics, the disaster is associated to people that are impacted by that, and how actually those tools and the mathematics you see as a science can better predict or better calculate the strength of the disaster, the risk of that. And if we go a little bit beyond, how we can avoid a disaster becoming a disaster, how we can understand a natural occurrence of a changing in the landscape by a landslide, by a flood, which are natural aspects, but that cannot become a disaster in terms of affecting people. So I think mathematics, it's a whole science, not only a science, but a philosophy in terms of how you deal with those sort of, what tools you can choose, what sort of uncertainty you associated to this, and what sort of solutions you can drive or derive from this suite of tools and science.
Modern statistics, which is beyond the old statistics that was frequentist. Now, for Bayesian statistics, there are many ideas that come from differential geometry. And there's a trend now to even use those techniques in the field of metrology. So no, I believe that differential geometry will help also this new area that is emerging of the mathematical tools for risk reduction on disasters. Organized and done by young people, and I feel like I am enjoying very much to see and enjoy novel work that will have a big impact in the future. And I really admire this young generation of not only the Brazilians, but their counterparts in England and Uruguay that came together here to share ideas and make a networking for future work.
Well, there are many applications of mathematics in climate science, and of course this is related to disasters. But in my line of work, we also employ a lot of mathematics. So we employ discrete mathematics, combinatorics and graph theory. We do a lot of statistics and stochastic processes as well. So I think mathematics is crucial for us to have a quantitative understanding of disasters and also make informed decisions.
Many subsystems interacting dynamically, and in a certain way this defines a network, meaning that the subsystems interact among each other, interchanging information, and so you can say basically that they are connected. So basically any system that has many features, such as the weather, for instance, oceans, atmosphere, soil, humidity, many features, you can cast it as a complex system. Then that would be my research field. 2 years ago, I was here in São Paulo for another of these kind of workshops, not related to climate, but actually to smart cities, I would say. And the interdisciplinary that involved there caught my attention. It was one of the most engaging conferences I have ever been. People from all different backgrounds were here, similar to what is happening now, and this brought up very horizontal solutions to problems that usually, if you are too focused in one particular expertise, you miss out. So this drove me here.
Well, mathematics obviously is, at least for me, it's a tool. So we really need good mathematical tools to understand and to predict climate variability. So that includes good numerical models of the atmosphere and the ocean and the climate in general, as well as complex mathematical techniques from statistics or for like complex networks or machine learning that help us analyze the data better.
There's a whole range of possibilities of interaction between my field of research and mathematics, including applied mathematics, statistics, and modeling. And I'm not a mathematician. So it's very interesting to have collaborations and partnerships to join different knowledges and to benefit both fields of research. I'm here motivated by the creation of networking, of partnerships, works in collaboration, because as we are working on a multidisciplinary field, it's important to join different people from different areas.
I think that we can identify a lot of mathematical fields linked with natural disasters. One is mathematical modeling and methods for solving partial differential equations and studies of nonlinear dynamics, and in particular these methods for complex system and also complex complex networks. It's one this recent research fields that I think that have a pretty good agreement with disasters modeling and prediction. Different people from different countries, different skills, mathematicians, statistics, people from computer science, meteorologists, oceanographers, well, all of these mathematicians, and so all of these different skills, it's in the same place. Just think this kind of brainstorm for generate new methods to attack this kind of issue. Disasters linked with climate change. I think that I'm very positive expectation from this workshop here.
Mathematics can help in any area of science, any area of engineering, and for disaster in particular is crucial, not only for developing new models, but also for the way that you can treat data. We are now living in an area in which data is very abundant, and basically you can obtain data in very different ways. The problem now is how you can deal or how you can treat this data, and then that's where mathematics can actually play a big role. But then how you can use this data is about how you can actually develop new models that are accurate enough and can represent the physics that we're interested in.
So I'm a numerical analyst, and what that means is I take equations that govern physical processes, for example, atmospheric processes, things arising in climate, weather, oceans, this kind of thing, and I construct ways to represent these things on computers, efficient ways. So I'm quite lazy, I get the computer to do the work for me so that I don't have to do the hard work. So, well, it's got a lot to contribute. So mathematics is one of the underpinning sciences of all of them. All physical processes are governed by either mathematics or biology. Right? I was told this. This is a quote from a famous scientist. Specifically, comes in an area called numerical weather prediction. So, numerical weather prediction being how can you efficiently represent the atmosphere on a computer? How can this be done in a fast and efficient way to meet some of the operational goals of big organizations? For example, in the UK, the Met Office or ECMWF, in Brazil, Semadine, and places like this. Very nice event. So this is a very nice conference. It is quite unlike other conferences that I've been to previously. It's very broad, very diverse. There's a lot of different people here with a lot of different specialisms, and so this is really good. It means I'm personally exposed to a lot of different areas that I wasn't aware of before, or maybe was aware of but didn't have a particularly good understanding. You get to meet people from these different fields who are able to even add insight to your own field, give you a perspective that you hadn't thought of before?
My feeling, mathematics is fundamental. So it's a powerful knowledge that we need to have to improve our models, to improve our understandings for the forecasting, and it will, in my opinion, it will directly contribute for the disaster reduction.
Maths is essentially at its very core a way of taking something that everyone experiences every day and putting it into a model and quantifying it in a way that we can use a computer and we can run things several times. So whereas disasters, when they occur, are tragic, when you run a disaster on a computer, you can run it hundreds of times over with no impact. The only thing you have to think about is the cost of the electricity, essentially. And if we can do that, you can actually end up saving lives by getting a good statistical picture of what's probably going to happen if and when they do happen in the real world.
I want to congratulate the organized committee for the event, and I want to sincerely see more events like this.